Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 19th video lecture on the course Applied Artificial Intelligence. In my previous video, I have discussed regarding the problem reduction, how the problem can be reduced into smaller sub-problems, and all the smaller sub-problem solutions can be combined to find out the final solution that I have discussed by using some classical examples like Aeronautical algorithm, as well as I discussed the AND or graph also. So in this video lecture today, I will discuss about some more concepts about the game playing. These are the topics to be discussed. What is game playing, the types of game, how to play a game, such in two-player games, the challenges in AI game playing, two-person games, status labeling procedure in game tree, how we can apply the status label procedure is very important concept, and the game tree example. This is the topic learning outcome for this game playing. After the completion of the topic, students can discuss the role of game playing in artificial intelligence and its significance to develop and evaluate intelligent agents capable of strategic decision making in competitive environments. So let me give an introduction about the game playing or the definition of game. As we know that everybody plays game. So game is a sequence of choices where each choice leads to a discrete set of outcomes. If you take the example of carom or chess, so two-player can play the game, or if you play the game with the help of system also, so that is nothing but a sequence of choices which is given by the user or by the machine, where each choice leads to a discrete set of outcomes. Some outcome will be generated after each sequence or after each action. Each sequence ends in a certain outcome, and each outcome has some definite value for the opening player, even for the same thing for the front player also. So for playing any game, we require the intelligence, we require the strategy, nothing but the rules or the procedures to play the game, as well as the decision making capabilities. These three things already I have discussed in my previous videos, like why intelligence is required, what is the meaning of procedure, why decision making is required. The same thing here, all the things are required for playing the game. These things are required for the human being as well as for the machine also. So AI game playing has been a major area of research and development nowadays, and game playing against the human expert has always been a fascination. Now let me discuss about different types of games. There are two different types of games in general. One is the perfect information games and second one is imperfect information game. Perfect information game means what? When both the players have the access to the same game state information about the game in progress. That means if both the players have the information about the game, then it is called as perfect information game. So for example, like the chess or checkers or tic-tac-toe or go game. Whereas in case of the imperfect information game, that means information is not shared, or if the player will not have the complete information about the game. So that means player do not have access to the complete information about the game. Like for example, the card game. The one person will have some knowledge, second person will have some knowledge, but both the person they do not have the knowledge about both opponent parties. So in that case, it is called as imperfect information game. Even dice game also. Few more typical simple cases for a game, like we can consider the two-player game, like turn-taking games, like players they will move alternatively one after the other. Then it is called as a two-player game. And zero sum game, which is very famous in game playing, especially in artificial intelligence, when one player's win is the other's loss. That means in zero sum game, the sum of all the wins and loss is equal to zero. That is why it is called as zero sum game. That means as two opponent party will play opponent to each other, somebody's win or loss will be balanced with front person's win and loss. That is why it is called as the zero sum games. And the next one is deterministic game. Deterministic means what? For like the outcome of action is known. For every action, the outcome of every action, if it is known in advance to the user or to the agent, then it is called as deterministic game. Like the tic-tac-toe game, somebody is putting, the front person is putting X, the front person, second person knows what he or she has to put. So that is called as deterministic. Tic-tac-toe game or chess game or name game also. Whereas the discrete game means if the game is a game is discrete if it has a finite number of states or configurations. Means every action can generate finite number of moves. Like if you take the 8 puzzle game, okay, if you consider the 8 puzzle game, then in that case what happens, every user, the agent can move either in the forward direction or in the backward direction or in the left direction or in the right direction. So we know the discrete movement, these possible 4 actions are possible for any user. So that is why this type of problems are called as discrete games, or discrete games like chess, checkers, tic-tac-toe or Go game. Now, let me discuss how to play a game. Everybody knows, if you ask a small kid also, he or she may know like how to play a game. So, a way to play such a game is to consider all the legal moves you can. That is not, these are nothing but the procedure how to play a game. So, consider all the legal moves you can make. Then compute new position resulting from each move. Evaluate each to determine which is the best one and make that move and wait for your opponent to move and repeat. So these process gets continued to complete the game. Normally, let search in two-player games. How the searching is done? As already we know that in artificial intelligence, many search algorithms are used where the agent can find out the path starting from the start node till the goal node. But in game playing concept, though it is a two-player game or zero-sum game, it is very difficult to implement using normal state space search techniques. So two-player games are common and it is easier to design, but AI agents use look ahead strategy to evaluate the future positions for success. So in every game playing in artificial intelligence, agent use these rules or the strategy which is called as the look ahead, using which it can find the best possible positions or the future positions before taking any decision. That is why the name is called as look ahead strategy. And the optimal solution can be found using the exhaustive search, but it is usually inefficient for complex games. Exhaustive search is nothing but our heuristic search like A star or AO star, BFS, best first search. But the problem in game playing is we cannot use the exhaustive search because the state space is very vast. That is what this is the challenges in AI game playing. So most of the interesting games have vast search space which we did not face in our normal search algorithms, whether it is our uninformed or our heuristic or exhaustive search. But in game playing, as the state space is very vast, because state space is very vast, when we can say if the same number of action is repeated for a multiple times, then definitely it requires more space and the space would be very vast. In that case the exhaustive search is impractical. So to make the search practical in game playing, normally we used to use Minimax algorithm or Minimax concept, as well as the alpha beta pruning concept. These are the famous techniques in game playing. Now let me discuss about the two-person games. When it is called as a two-person game, games with two opposing players means two people will play opponent to each other. Then it is called as a two-person game or two-player game. It is also called as min and max. Okay, so as min max, it's a famous game strategy in artificial intelligence, especially in game theory. So two-player game or two-person game is also called as min and max. Normally, max moves first in every game. This is a 99% chances like max player will move fast, then they take the turn, then min player will play, and so on. This process gets continued. So, in game terminology, a move comprises two steps, one by the max, another by the min, and alternatively, they move opponent to each other. So Max, in this two-person game, Max wants his strategy to find a winning state. That means no matter what Min does, always Max player will try to win the game, and Min player also will try to win the game like the Max player, or at least it tries to prevent the Max from winning. And one important concept in two-person game is nothing but the full information and partial information. Full information, when we can say when both min and max player will have the complete knowledge about the state, space, or the environment, then that is called as a full person two-player game. Whereas compared to full person, another one is the partial information. That means one player only knows the part of the environment, other player may not know the complete information about the environment. So in that case is called as the partial information two-person games. So some aspect may be hidden from the opponent or from both the players. That is why it is called as partial information game. Now, this is the very important concept I want to introduce. I want to discuss over here what is the meaning of status labeling procedure in game tree and how to apply the status, how we can assign the status leveling in the game tree. Normally, the status means there are three different type of status are there for the nodes in a tree. That is, the first status is win, which we can denote using the W, and then the status is loss. It can be denoted as L, and one more status is draw. It can be denoted as D. So each non-terminal node in the game tree can be labeled as these three status, either win, loss, or draw, by using the bottom-up process. So that means what we have to start from the leaf node, because in the case of status labeling procedure, all the status symbols like win, loss, and draw will be given to us for all the leaf nodes. Based upon the leaf nodes, we have to follow till the root node by following the bottom up process. But to how we can allocate these three status to all the non-leaf nodes, for that some procedures are there. So this is the procedure for status labeling in game tree using bottom up procedure. So as I told, this procedure is implemented using a two-player game, where two-player means one is max player, another one is min player. Let me discuss about first max node, which is a non-leaf node. Then what is the meaning of leaf node? Another one is non-leaf node. So if I draw the diagram like this, okay, so if we draw like this, so these are, so this one, this one, this one, this one, these four are leaf nodes. Leaf node means the node which does not have any child, that is called as leaf node. Other than leaf nodes, that means this one, and this one are called as non-leaf nodes. Now in our state, now alternatively, in this two-player game, two person are there. One is max player, another one is min player. So if max player will start the game, then the next level min player will play, and in the next level max player will play, and so on. So now, as per this status labeling procedure, for all the leaf nodes, status should be given to us. Based on that, we have to find out the status of all these three non-leaf nodes. Now for that, this is the procedure. Here it is given on the screen. I hope it is visible to you, can understand. Now we'll discuss first, if the J is a non-terminal max node. we'll discuss about non-terminal max node. We are calculating the status level for the max node which is non-leaf or non-terminal. So status of the max node we can write, okay, let me write over here so that you can understand max node which is non-terminal. So when we can say it is win if any of the j successor is win. That means if any one of the successor of the child is win, then this max node can be represented as win. Then when we can write L, if all the j successors are lost. That means if both the successors are L, then in that case we can write the node as L. These nodes are nothing but the max non-leaf node. These are the leaf nodes. Already it is given to us. So whenever both the leaves are L, then max node can be represented as L. When it is W, child is any one of the child is W, then we can write the max node as W. And another one is draw. If any of the j successor is draw and none is win. That means if any one of the successor is draw D but not win, none is win. No one should be win. But that means D combination is possible. In that case, I can write the max node as D, or else I can write if D and L. Okay, D and L means one of the child is D, another child is L. In that case also we can write as the node as D. So these are the cases. If any one of the child is W, then the max non-leaf node can be written as W. And if both the successor are L, then in that case the max non-leaf node can be represented as L. If any one of the successor is D, any one of the successor is D means but none is win. In that case, that means both the successor D. In that case, I can write the non-leaf max node can be D. Or else if any one of the successor is D and another one is L, in that case also we can write as D. So in all the cases, this is the way we can represent the max non-leaf nodes. Same thing for min non-leaf nodes based upon the status of the leaf nodes. The second one, if j is a non-terminal min node, then status of j we can write win. Now the condition is for min non-leaf node. So when we can write win if all the j successor are win. That means both the child should be win. It's not like two children. It may be 3 children or it may be 4 children. If all the children will have the win status level, then the non-leaf min node can be W. Second one is loss. If any of the j successor is loss, means any one is L. In that case, the min non-leaf node can be L. Then last one is draw. If any of the j successor is draw but none is loss. That means either both the successor or all the successor are D. In that case, I can write D. Or else in any one of the successor is D, another one is W. In that case also I can write D. But it should, in place of W, it should not be L. It should be W only. Okay. It should be W. If suppose in place of W I'll write L, it would be L. It would be L, right? So like this, the status labeling procedure can be maintained for all non-leaf nodes. Now I will show you one of the example where easily we can understand. Already the solution is given in this tree. So in this tree, as it is a 2-player game, so max player starts the game. Then alternatively min, then max, then first max, then min, then max, okay, then min, then max, and the min. Okay, this is the 0th level. This is the first level, second level, third, fourth, and fifth. Now here all the levels are already given, so you may get confused. So I will write over it so that you can understand. So how in this tree, how we can assign the status of all the non-leaf nodes. Now in this game tree is to make it visualize or to make you understand, I have taken 2 different symbols. One is the square symbol which indicates the max. Another one is the circle symbol which represents the min player. So alternatively, both the player are playing opponent to each other. So if you see in this diagram, let me find out what are the leaf nodes. This is one leaf node which is already given as L. Already it is given. Okay. And first we have to find out the leaf node. These are the leaf nodes which is already given as W. Here also it is W is already given. Now these two are also leaf nodes, because wherever we do not find any child, that is considered as the leaf node. This is also leaf node. These two are also leaf node, as well as this is also leaf node. So these are the leaf nodes, and their status are already given below it. I think it is visible to you. Now we have to find out the status of the non-leaf nodes by following the bottom-up process. So as it is a bottom-up process, we'll start from the last level. So these two are at the last level. Now, if these two are at the last level, what is the next level? This one we will find out the status of this one. What would be this level is present at the max layer. So for max layer, if both the players are L, definitely it will be considered as L. Done. Now this one is already given as W. This one we found as L. If one is W, one is L, what would be the successor? What would be the parent status? Parent status, it is in the mean player. So it would be L, because if any one of the successor is L, it would be considered as L. Now same thing for this one. This one is L and this one is L. What would be the value for this one? This node, this parent is present. You have to check where the parent is present. The parent is present in the max player. So as per the max rule, if both the successor are lost, then it is considered as loss. Now you can see here, this is loss and this is loss, and the parent is present in the max layer, so that can be considered as loss, right? Now here only one child is there, so definitely the parent would be L only, and parentage it is in the max layer. Now come here, these two are W, win, and the parent is present in the mean player. Okay, because the circle means mean, no need to check this one also, it is the mean. So mean can be W. If both the players are W, definitely mean will be W. Now one is L, another one is W. So what would be the parent status? So parent status would be W, because it is a max player. Max, as per the max, if any one of the successor is W, definitely it would be considered as W. Now this layer is done. Up to this layer is done. Now we'll go up. Now this is L and this is L. And what would be the status of this one? The status, it is a mean player. If both of the successor are L, that means it is considered as L. It is also done. Now this parent is having only one child, so it is W. One of the child is W, so parent would be W only. So this is also done, and it is already given. Now we'll move. This layer is completed. So like this, you have to move up and up by following all these mean rule and max rule. Finally, the root node. What would be the status for the root node here? Because all the three children is having different status. One is W, another one is L, another one is L. So as per the max player rule, max player, non-leaf max player, if any one of the children is, or if any one of the successor is W, definitely it is considered as W. So like this, we can assign all the status W and L. Now let me erase. I will tell you one more thing. Here you might be observing some +1 and -1s are given. So to cross verify, actually, +1 means it is a good move and -1 means it is a bad move. That means whenever we are writing loss, you can mention it as -1, and whenever we are writing W, you can mention it as +1. Now from the bottom, you can observe this is -1, this is -1 because of L. So -1 and -1, what would be the max between -1 and -1? So definitely for loss it is -1, and it is satisfying because already we have written L, so it is -1. Now this is W and this is L. So this is +1. So what we can write here? +1 and this is -1. So definitely it would be -1 because we are finding the minimum between +1 and -1. So it is considered as -1. Same thing here, -1, here -1. What is the max value between these two for this one? It is -1 only. So like this, we have to follow -1 +1 till the root node. Okay, for our clarification, wherever we have mentioned W and L, it is really correct or not, we can verify using this from the root node, from the leaf node. First you assign for L is -1 and W is +1, and verify from the using bottom up process. I will show you one more example which I have taken. I hope you might have understood this example, how to assign the status label for non-leaf nodes. This is one of like the same thing. Let me repeat over here. The max node here, it is represented as the square node. Min node, it is represented as circle in this previous example. And the level of edges we have written L and W. For every L means it is a good move, we have represented as +1, and for every bad move, that is represented as -1. For every good move, which is called as W, that is +1, and for every bad move or loss, that is called as -1. So leaf nodes are marked as only W and L. Actually, in this example, nowhere it is mentioned D, so no need to worry. Only two things, using these two symbols, we have propagated from the leaf node to the root node. The same procedure is followed. If D is given, we have to follow the strategy of the non-leaf status labeling for the non-leaf max node and min node. Now, this is one of the example which I have taken directly from the Saro's Kosik book. Now, you can observe the first player is the max player. This one is the max player. Second player is the min player. Third player is the max. Third time next chance max. Then min player. And all the status of the leaf nodes are already given. One is W, another one is L. Here it is L. Here it is L. Here it is W. L. W, L, W, D and L. So to make you understand how to use D, that is why I have taken this example. So we have all these values, all the status of the leaf nodes are already given. Now we have to find out the status of the non-leaf next layer, that means for this max layer. So what would be the value for this one? As it is the max node here, one of the successor is W, so it is considered as W. Now for this, one of the successor is L, so it is considered as L. Now one is L, one is W, so it can be W. One is W, another one is L, so it is W. Same thing, here it is W, so only one child is there, W, so parent would be W. One of the successor is D, so definitely the parent would be D. Now this layer is completed. Now propagate to the next upper layer, which is min layer. So min layer, one is W, another one is L. So definitely the status is L. Here one is W, another one is W. So definitely the status is W. Here one is W, another one is D. So definitely the status of the non-leaf min node will be D. Now one is L, another one is W, another one is D. Definitely the status of the max non-leaf node would be W. So like this, we can apply the status labeling for all the non-leaf nodes. One more example, let me show you here. This is third example. All the status of the last level is already given. One is L, which is the max player. Here the first player is min, next player is max, next is min, then is max. So for max layer, all the status are already given. L, W, here L, here it is W, this is L. Okay, this is W, this is W. Here it is W, here it is L, and here it is W, it is given. So now we have to calculate the non-leaf node which is in the min layer, because from the leaf node we have to propagate the status level to the next level. So one successor is L, another one is W, and it is in the min layer. So status would be L. So here only one successor is there, which is L. So definitely the status would be L. Here one L, one W. So status would be L. Here two W's are there. Status would be W. Here one W, one L. Status would be L. Here one W, definitely status would be W. Now the same level will be propagated. The status level will be propagated to the max player. So both the successor are L. Definitely the parent would be L. Here one successor is L, another one is W. So definitely parent would be W. While calculating the parent, just you check where it is present. It is in the max player or it is a min player. Based on that, you follow the strategy and assign the status level. Now here one is L, another one is W. The status of the max non-leaf node would be W. Now one is L, another one is W, another one is also W. So definitely the status would be L, because it is a min player, min non-leaf player. If any one of the successors is L, definitely the parent would be L. So like this, we can assign all these status levels to all the leaf nodes whenever both max and min player play opponent to each other. So this is all about for this video lecture. I have, for preparation of this video lecture, I have followed Soros Kosek book for artificial intelligence, even for the website which is visible on the screen. I hope you might have understood and you might have enjoyed this video. Next class, I will discuss some more concept about this game playing, as well as I'll discuss about one of the important game that is called as name game. Bye, thank you.
Like, share and subscribe. Hit the bell icon for more updates.